Hello. In this video, we're going to explore Boolean operators. Boolean operators are wonderful tools that can be used when you're programming to take larger conditional structures and shrink them down. What I like to say to students is that with a little more planning, you're going to have less code. Often what happens is I can give a problem to a student and they'll come up with a solution really quickly, and that solution might be 100 lines of code. But often then my question is, can you do that same solution in 10 lines of code? Really, a good thing to focus on as a beginning programmer is the elegance of your solution or the efficiency of your solution. There's lots of great discussions that can happen with that. Also, we start with looking at some gate diagrams, and the reason we do this is because if you're interested in exploring any type of field that deals with circuitry, so a number of engineering fields will explore circuitry, as well as computer science fields. Having an understanding of this gate logic is really important. So it's a great place to kind of start to introduce it. And if you really want to look up some more, which I encourage you to, is some other ones to look up are NOR, NAND, and XOR gates. Okay, so let's dive in, shall we? So we have three types of gates that we're interested, or Boolean operators, we could say. The first one is AND. And in Java, we represent it with two ampersigns. And symbolically, it looks like this. In Boolean algebra, the operator looks like that. The next one is OR, and it's represented with two vertical lines. The gate looks like this, and in Boolean algebra, it's represented with an addition symbol. The last Boolean operator is NOT. In Java, we represent it with an exclamation mark, and the gate looks like this. And what we do in Boolean algebra is if we want the not of some value, we simply put a line over it. So we could do A and B, we could say A or B, and we could say not A. So we could actually fill this diagram. If I had A as this input and B in this input, the output would be A and B. If I had A on this input and B on this one, the output would be A or B. If I had A going into this NOT gate, the output would be A NOT. So now the question comes, well, what is A and B, and what does A or B mean? So I have some truth tables here, and what we're going to do is we're going to populate these just to make sure we understand the difference between AND, OR, and NOT. So what we're going to do is we're going to actually fill this in by looking at Boolean inputs, Boolean values. So Boolean values, just to remind us, are, that's not a very good R, let's write that again, are true or false. And sometimes people will write these with 1 for true, 0 for false. So for the first gate here, we're going to imagine this input is A and this input's B, and the output, like I said, is going to be A and B. So in this truth table, we're going to give A, B, and we're going to say A and B. And now what I want to do is try and imagine all the possible combinations of A and B, given their Boolean values. So we could have true, true. We could have true, false. We could have false, true. We could have false, false. So AND returns true when both of the inputs are true. So if I have true and true, the output's true. If I have true and false, the output is false. If I have false and true, the output is false. If I have false and false, the output is false. Let's look at the OR gate. If we name these inputs A and B, we have A and B. And if you start to work a lot with these types of gates, you get very good at writing truth tables. And there's a neat little trick you can do. If you have two inputs, true, true, false, false in your first input, true, false, and you've now dealt with all possible combinations. And actually, there's a pattern you can apply if you have 3 inputs, 4 inputs, 5 inputs. And it's something to explore. So now let's look at A or B. And the OR gate works where if one or the other is true, the output is true. So true, true would result in true. True, false would result in true. False, true would result in true. False, false would result in false. Our last gate, not. So we have A as the input, and the output's going to be not A. So this simply flip-flops it. If the input is true, the output is false. If the input is false, the output is true. And so this is let me rephrase that. These are your three core logic gates that are really important and are what we are going to use to build our Boolean operators as we continue to explore conditional structures in Java. Anyways, I hope that helped. Have a great day.